When we drill into the Antarctic ice sheet, we're effectively drilling into the past. We can see information in the ice that almost looks like tree rings. We can count annual layers, so we can date the ice very well. But we know that ice in Antarctica doesn't really melt from one year to the next, so the ice builds up year upon year upon year. So by drilling into it, we're drilling slowly into the past. So if I go all the way to the bottom of the ice sheet, I can go back tens of thousands of years and look at and the things that we measure in the ice will tell us about the climate. We also can extract the bubbles out that are trapped in the ice, which tells us about the atmosphere. So we're able to bring together a record of the climate and the atmosphere and to see how the two interact. And what I wanted to do is display ice from Antarctica in a sort of melting manner, so that it's melting away as you look at the exhibit. And that's, if you like, to try and capture the fragility of the polar landscapes. But also I wanted to capture a sample air from 1765, which is right at the dawn of the Industrial Revolution, and put a sample of the air from 1765, uncontaminated by modern air, on display. So that this will be air that's got levels of carbon dioxide from the pre-industrial era, encased in glass, in something that kind of mirrors the ice core. So we've got an ice core and a piece of glass that mirrors it, with two completely different aspects of what we're trying to capture. One, the fragility of the landscape, and one, the pre-industrial atmosphere.
We've got three pieces. The first piece is called 1765, and it is a glass sculpture. And we've left an internal core in a cylinder of glass, and the internal cylinder has a volume of air that's been extracted from an ice core, and that air has been inserted into the glass as a kind of treasure from 1765.
1765 is significant because it's the internationally accepted threshold of the era, the epoch that we're in now, known as the Anthropocene, the era when the climate has been influenced by man, and it started in 1765 because that's taken as the threshold when we really started using fossil fuels at increasing scale. So the atmosphere has been modified by mankind since that point. My role as engineering this was about how do we get the air into the ice, and we explored ideas of sealing it in a little glass ampule, the type where you snap the end off, and then casting all of that. It turns out that the kind of glass you need for those little ampules has a very high melting point, and so casting it into one big block, that proved to be a real challenge to do within the timescale of this exhibition. What we chose to do to capture the air inside the glass was cast it using a glass type which is commonly used for artistic glass castings, with a cylindrical hole down the centre. It's cast this way up, let's say, and with a cylindrical hole, and then fill that hole with a fluid which has got a very close refractive index to the refractive index of the glass, so that it almost disappears as you look through the glass. Seal that with a very clear silicone sealant, and then turn it upside down, and Robert injected this special sample of air up into the fluid so it then forms a bubble inside the glass.
The second piece is called Ice Core, and that is again another cylindrical work which we've left an open void for visitors to touch, because one of the things that we're interested in exploring is the proximity to the subject, and the idea of not only touching physically but being in touch is something that we think is quite important.
The key challenges in displaying the ice was how do we make it available and for people to interact with it, see it, touch it, hear it, without it all melting at a rapid rate. At the same time, we wanted to avoid having to refrigerate it, because we imagined we could put it in a little freezer and it could gradually come out of the freezer and just melt away, but then we'd have to consume electricity all the time as we preserved it. And also, how do we illuminate it so that you can see what's going on inside the ice, see these bubbles? So we opted for a vertical display where the ice slides down a clear plastic tube. In the upper part of the tube we can insulate it to control the rate at which it melts. If we insulated it completely and didn't expose it, we'd hardly ever get a drip. And now and then you'd get a drip, now and then you'd get a bubble popping, but it wouldn't be a very lively and engaging exhibit. So we've aimed to adjust that so that there's a steady drip, there's a popping of ice, but at the same time it doesn't all melt away too quickly.
And the third part is a work called Ice Stories, and we've created a pathway from the front door of the Glasgow Science Centre, and we've created a pathway that leads from the door to the exhibition and then from the exhibition back to the door. So there's climate scientists from around the world have been invited to say something prescient about their time in the Arctic and Antarctic, and that we've inscribed these words on the floor. So it's kind of created a space of physical transit and hopefully some kind of dialogue and exchange of something special that the scientists are telling us. So the exhibition has an ambient soundtrack. It consists of two things. And the first thing is based on a piece by Maurice Ravel called Gaspard de la Nuit. And Gaspard de la Nuit is a guardian of treasures, and I've always thought of the British Antarctic Survey Ice Core Lab as a place of treasure. And Ondine is one of the pieces from Gaspard, and it tells of a water sprite who lures her love beneath the waves. And I've always thought that this idea of drilling ice cores from beneath the ice is a counterpoint to some of my actual audio recordings that I've been developing over the last 5 years. And I like this idea of the sort of human compositional qualities and the kind of non-human compositional qualities to be brought together, and hopefully it would be quite a kind of balanced sonic experience.
So trapped deep in the ice are tiny bubbles of atmosphere. So actually about 10% of the volume of the ice is air. And as it gets deeper in the ice, these air bubbles get more and more compressed by the overlying weight of the ice. So when the ice starts to melt, these bubbles pop back into life. And you can hear them crackling. It's like, if you imagine ricicles when you pour your milk onto them, they go snap, crackle and pop. If you hold a piece of ice from deep in the ice sheet against your ear, you can hear all the air bubbles popping away. And what you're doing is releasing that old atmosphere. And I can hear them. And that's just almost the most evocative sound that I've ever heard in Antarctica. You just listen to those air bubbles popping away. And the ice, if you put it on your warm hand, it starts to shatter and break, because as it melts, the air bubbles come back to life and they snap and break, and the ice falls apart in your hands. It's a beautiful visual and a beautiful sound, and for me, it's the most evocative part of drilling ice. From the ice cores, we can see how climate is changing over many thousands of years. So, during my career, I've worked on ice cores that go back as old as 800,000 years. And in that time, we've gone through an ice age and a warm period 8 times. In each of those periods, the carbon dioxide drops during the cold period, and it warms up, it increases to about 280 parts per million during the warm period, just like we'd expect to see at the beginning of the Industrial Revolution. And then you get that sudden rise as the Industrial Revolution takes hold all the way to the level today, 415 today, and continuing to rise every year at 3 parts per million per year. And I think during my career, I've seen that happen. I was born in a world where the level of carbon dioxide was 315 parts per million. Today it's 415 parts per million, so it's gone up a third in my lifetime, and I'm not that old. And in Antarctica, I don't actually really see the changes visually. When I work in Antarctica, I can't tell the continent is changing. But from the data we've got, from looking at the melt rate, from looking at the levels of the Antarctic ice sheet, how it's beginning to lower in places near the edge. If the ice sheet is slowly getting lower, that's melting away ice, that then adding to the sea level and causing sea level to rise. I think what I'm asking of people is that they think about our atmosphere, think about the fact that carbon dioxide is increasing, and the fact that we're all contributing to that in the way we live. and eat and travel, that's all contributing to the levels of carbon dioxide in the atmosphere, which is causing the climate to warm, which in a sense is also causing the fragility of the polar ice caps. If they start to melt, that adds to sea level rise, and that's another aspect of climate change that we really want to avoid over the next century. So we're trying to limit the amount of carbon dioxide, limit the amount of sea level rise. I'm asking people to think about those two aspects and think about how they could contribute towards, in their own personal way, reducing the impact on the atmosphere.
We'd like them to take away a sense of connection, proximity to a subject that's quite conventionally inaccessible, and we like to collapse that distance, both temporally, spatially, politically, historically, and invite a sort of closer, greater awareness of the past, present, and future.